In this video, I'm going to look at the three remaining quadratic inequality examples from the previous video. If there's one problem you want to skip to, feel free to do that. I'm going to start off with x to the 6th is greater than or equal to x to the 4th. And so once again, the way we're going to solve this is going to be the same as last time. We're going to want to start by finding our zeros. So we can solve this equation right here. So x to the 6th minus x to the 4th is greater than or equal to 0. We'll factor out an x to the 4th. So we're going to get x to the 4th times x to the squared minus 1 is greater than or equal to 0. And we can just factor out this last term here, or factor this last term, so that's going to be x to the 4th, and then x plus 1, and x minus 1, and that's greater than or equal to 0. So finding our zeros is going to be pretty easy here. For this first part, it's just going to be 0, because 0 times anything is 0. Right here, it's going to be negative 1. And here, it's going to be positive 1. So we can create our number line. It's going to look like this, and we'll have negative 1, 0, and 1. And now we have 4 intervals we want to test. Negative and -1, -1 to 0, 0 to 1, and 1 to infinity. And so now we need to pick a point for each interval to test. So for this one, I'll just go with -2. Here I'll do -1/2. Here I'll do +1/2. And here I'll do 2. And so now we want to test each one of these points and see if it satisfies the inequality. And we're going to plug it into this right here, that whole thing. So starting with -2, if we do -2 to the 4th, that's going to be a positive number. And then -2 plus 1, that's going to be a negative. -2 minus 1, that's also going to be a negative. And so this will work because we have a positive times 2 negatives, which is a positive times a positive. So this range is going to be in our solution, or the numbers in this interval are going to be in our solution. So moving on, we're going to test -0.5. So -0.5 to the 4th, once again, that's going to be a positive number. And then -0.5 plus 1, also a positive number. And -0.5 minus 1, that's going to be a negative number. And so this, so that inequality is not true. And so the numbers in this interval are not going to be part of our solution. Moving on to 0.5, once again we're going to have a positive number here. Then we're going to have another positive number. And 0.5 minus 1, that's still going to be a negative number. Oops. Yeah. And so just like before, that is not going to be true. So this interval will not be part of our solution. I can't see it. And so finally moving on to 2, we have a positive number. Then 2 plus 1 is positive. 2 minus 1 is still positive. And a positive times a positive times a positive is a positive number. So that's going to be true. So this interval is going to be a part of our solution. And so now we have negative infinity to negative 1. And so we need to test our negative 1 to see if it's going to be inclusive or exclusive. So negative 1, if we plug that into our inequality here, we're going to have negative 1 plus 1 right here, which is just going to be 0, which means this whole thing is going to be 0, which means it's going to be part of our solution, so we'll have a square bracket. And then we're going to have 1 to infinity. And once again, with 1, we need to test that point. So 1, if we plug it in right here, it's going to be 1 times negative 1, and that's going to be 0. So this whole equation, or the whole side of this inequality, is going to be 0. So this is going to be true. So we'll include that in our solution. So our answer, or our solution for x to the 6th is greater than or equal to x to the 4th is going to be negative infinity to negative 1, and then we're going to have a square bracket, and then union 1 to infinity. One thing you want to watch out for when you're solving this inequality, and this is a pretty easy mistake to make. So something that you could do is divide by x to the 4th, and so if you did that, you would end up with x to the 2nd is greater than or equal to 1, and then you'd bring the negative 1 over, so you would have x squared minus 1 is greater than or equal to 0, and then you'd factor it, so x plus 1, x minus 1 is greater than or equal to 0, and you'll notice right here, it's kind of similar to what we had right here, except we are missing the x to the 4th. And so that means that if we try to find our zeros, we'd have negative 1 and 1, but we would be missing the 0. So then if we try to solve it, we wouldn't get the right answer. So you always want to make sure that when you're solving or finding the zeros in your inequality, that you have all the possible zeros included. For this next problem, I'm going to look at x plus 3 over x plus 4 is greater than or equal to x plus 1 over x minus 2. In this problem, it's really just a bit more algebra than the previous two, but the idea, once again, is still the same. So we're going to start off by getting this into a form where we can find the zeros. So we'll start off by moving everything onto one side. It's going to be minus x plus 1 over x minus 2 is greater than or equal to 0. And so now we want to combine this into one fraction. And so we're just going to multiply this, the left part by x minus 2 over x minus 2, and the right by x plus 4 over x plus 4. And that's going to give us x plus 3 times x minus 2 minus x plus 1 over x plus 4. And then the denominator is going to be the same for both of them, so we can just combine these. This is the one. X plus 4 times x minus 2. And so now the bottom part of our fraction is fine. We can find the zeros for that. But we're going to want to combine this top part so that we can find the zeros for that. So if we multiply these out, they'll give us x squared plus x minus 6. That's the left part, minus x squared plus 5x plus 4. And once we cancel all our terms, we're going to get negative, and that's over x plus 4, x minus 2. These are still greater or equal to 0. And so once we cancel all the terms, we're going to get negative 4x minus 10 over x plus 4, x minus 2 is greater than or equal to 0. And so now we just need to factor this, and we can take a negative 2 out of there. And that will give us negative 2x plus 5 over x plus 4, x minus 2. And so now that we have this, it's greater than or equal to 0. And so now that we have this, it's going to be pretty easy to find our zeros. For the top, it's just going to be negative 5 over 2. For the denominator, it's going to be negative 4 and 2. So now that we have our zeros, we're going to draw a number line. And once again, we're going to place all our points on this number line. So we're going to have negative 4 on the left, negative 5 over 2, and 2 off here. And so once again, we have to pick a point from each one of these intervals. So I'm going to test negative 5, negative 3, then here I can go with 0, and here I'm going to go with 3 as my test point. So once again, I need to plug this in to our equation here, and if this equation is true, then every number in this interval will be a part of our solution. So we're going to start off with negative 5, and so we're plugging it into this here. And so negative 5, if we plug that into the top, we're going to get a positive number. And if we plug it into the bottom, we're going to get a negative number and a negative number. So we're going to get a positive times 2 negatives, and that is just a positive number. And any positive number is going to be greater than or equal to 0. So this is true. So we know that all the numbers in that interval will be included in our range. Moving on to negative 3. So we plug that in, and on the top we're going to get a positive number once again. Because it's going to be negative 2 times negative 1, so that's a positive. And on the bottom, we're going to get a positive number and a negative number. And that's going to give us a negative number, and a negative number is not greater than or equal to 0. So this interval here will not be included in our solution. Then we can just plug in 0, and on the top we're going to get a negative number because it's going to be 5 times negative 2. So 0, we're going to get a negative. And on the bottom, it's going to be x plus 4, so that's going to be a positive number and a negative number. And so negative over a negative, that's going to be a positive number. So 0, so all the numbers from negative 5 over 2 to 2 will be included in our solution. And then finally, we can do 3. So when we plug that in, we're going to get a negative number on the top. And then on the bottom, we are going to get a positive number and a positive number. And so positive times a positive is positive, and a negative over a positive is going to be negative. So this would be negative, and that will not be in our solution because that is not greater than 0. So now that we have our intervals, we're going to need to test our endpoints. And so the endpoints we're going to need to test are going to be, well, the first one is going to be -4 because our first interval in our solution was -infinity to -4. And so when we look back at our equation here, if we plug in -4, we notice right away on the bottom there's an x plus 4. So if we plug in -4, it's going to be this, the denominator is going to be 0, and so we won't get a solution from that. So we're just going to put a parenthesis around the -4. Then we'll have a union. And then our next interval we said was -5/2 to 2. And so we're going to need to test both of those. So -5/2, you'll notice if we plug it into the top, we're going to get -5/2 times 2, because we're plugging in for the x here. So that's going to be -5 plus 5, and that's going to be 0. And so 0 times anything is going to be 0. And so it doesn't matter what we get on the bottom. This is just going to be equal to 0, which satisfies that inequality. So we're going to include -5/2. And so for 2, we'll notice once again if we plug it in here, we're going to get 2 minus 2, and that's going to be 0, and we can't have a 0 in the denominator, so we won't have a solution for that. So it's just going to be -infinity to -4 union -5/2 inclusive to 2, and this is our solution. So in this last problem, we're going to look at x/2 is greater than or equal to 5/x plus 1 plus 4. So we're going to approach this the same way we approach the other problems. We're going to move all the terms to one side and factor it so we can find the zeros. So we'll move everything to one side, and we have zeros greater than or equal to 5/x plus 1 plus 4 minus x/2. So now we need to combine all these terms, and so you guys know how to do that. And once we do that, we're going to get 10 plus 8/x plus 1 minus x plus 1, and that's going to be over 2 times x plus 1. And so from here, we just need to expand everything, and then cancel the terms on the top. So we'll get 0 is greater than or equal to 10 plus 8x plus 8 minus x squared minus x. And so we can, so it's going to be 0 is greater than or equal to, and this is going to be over still 2x, or 2 times x plus 1. And so I'll write this a bit lower. So we're going to have 0 is greater than or equal to, So we're just going to have a negative x squared. And then for our x's, we're going to have negative x plus 8x, which is just going to be 7x. Then finally, so we have those two terms. We're going to have 10 plus 8, so that's going to be 18. And this is still going to be over 2x plus 1. In this one, we don't need to expand because it's already factored nicely. So moving on, we are going to want to factor this. And if it makes it easier for you, you can write this as 0 is greater than or equal to. You can just pull out the negative. So it's going to be x squared minus 7x minus 18 over 2x plus 1. So now we're going to just want to factor this. And this works out pretty nicely. It's just going to be 0 is greater than or equal to, let's see, it's going to be x minus 9 and x plus 2. And that's going to be over 2x plus 1. Right, because we have negative 9 plus 2 is going to be negative 7, and negative 9 times 2 is negative 18. And so now this is factored pretty nicely, so we can find all our zeros. And on the top, it's going to be 9. It's going to be negative 2. And here it's just going to be negative 1. So these are our zeros. So next we draw our number line, right? And we're going to put negative 2 on there, negative 1, and 9. So just like before, we are going to want to test a number in each of these intervals. And if one number in a certain interval is true, then all the numbers in those intervals will be true and they'll be part of our solution. So for this interval, negative infinity to negative 2, I'm just going to choose negative 3. Here I'm going to choose negative 1.5. Once again, it doesn't matter what values you choose as long as they're in the interval. Here I'll just choose 0. And here I'll choose 10. And so we're testing all these numbers on this equation here. So when we plug in negative 3, we're going to get, I'm sorry, so I meant to write a negative here, because remember we had the negative here when we factored it. So I'm just going to write that in here, and the rest will be the same. And that's important because when we're finding our solutions, so remember this negative number, we're going to want to keep that in mind. Even if we're not plugging anything in there, it's still going to affect the value. So we're going to have a negative number here, and when we plug in negative 3, we're going to have negative 12, which is negative, and then negative 3 plus 2, that's still going to be negative. And that is going to be over a negative number, because negative 3 plus 1 is negative. And so we're going to have, this is going to be negative, or this is going to be a positive number because we're going to have a negative over a negative. And so this is not going to be part of our solution, right? Because a positive number is not going to be less than or equal to 0. So it's not going to be part of our solution. Yeah. So you always want to make sure to pay attention which way this sign is pointing when you're plugging in your numbers. So next, moving on to negative 1.5. Once again, we're taking this negative into account. And for this next number, we're going to have a negative 1.5 plus 2, that's a positive. That's going to be over negative 1.5 plus 1 is going to be negative. So this whole thing is going to be negative, and a negative number is going to be less than 0. So this is true. And then finally, we have, I'm sorry, not finally, we have two more. We have to test 0. So once again, taking this negative into account, and then 0 minus 9 is negative. 0 plus 2 is a positive. And then 0 plus 1 is also positive. So this whole thing is going to be positive. Sorry. And it will not be a part of our solution because the positive number is greater than 0. And so for our last point, we're going to look at 10. So once again, we're taking the negative into account. 10 minus 9 is positive. 10 plus 2 is positive. And 10 plus 1 is positive. So we're going to have a negative number over a positive number, which is going to be negative, and that will be a part of our solution. So this range here is going to be part of our solution because that is less than 0. And so finally, just like before, we're going to test our endpoints. And so if we write out our intervals that we had, so we had negative, I'm sorry, I drew the wrong thing on here. It should be this interval. So we're going to have -2 to -1. And so we're going to need to test each one of these. So -2, if we plug that into our equation, right here, it's going to be -2 plus 2, and that's going to equal 0. And so it doesn't matter what the other values are, this whole thing is going to be equal to 0. And so this is going to be true. So it's going to be part of our solution. So we'll have a square bracket like that. For -1, if we plug that in onto the bottom here, we're going to get a 0 in the denominator because -1 plus 1 is 0. And so that will not satisfy this inequality because you can't have a solution. So we're just going to put a parentheses like that. And we're going to have our union. Then our next interval is going to be 9 to infinity. In infinity, we can just put a parentheses there. And then 9. So once again, going back to our equation, we're going to have, if we plug it in, we're going to have a 9 minus 9 here, which is going to be 0. And it won't matter what the other values are. This whole equation is going to be 0. And 0 is equal to 0, obviously. So this will be a part of our solution. And so this is going to be our answer right here. We're going to have -2 inclusive to -1, then a union 9 inclusive to infinity.